Alright, so today we're actually going to look at the second part of solving systems of equations, and that is by substitution. So, I'm learning to solve systems of linear equations algebraically. Let's go ahead and take a look. When solving systems of substitution, you want to first solve one equation for one of the variables, then substitute the resulting expression into other equations to replace the variable and then solve the equation. Last, substitute the solve for the other variable. So, Ms. Younger just rambled on lots and lots and lots. Let's put this into practice. Alright, we want to get one variable by itself. So when I look at this, I have a 5x, I have a negative 3y, I have a 2x, and I have a y. This y has a coefficient of 1. So we're actually going to use this second equation to take a look at what's going on. We're going to isolate that y. So I have 2x plus y equals 7. My goal is to get y by itself, so I'm going to subtract 2x from both sides. So I have y equals negative 2x plus 7. Now that I have a variable isolated all by itself, I'm going to take that knowledge and I'm going to substitute it back into the first equation. So sub into equation 1. So when we look at equation 1, we have 5x minus 3y equals 23. However, I know what y equals. Y equals negative 2x plus 7. So wherever I have y, I'm going to put these placeholder parentheses. So 5x minus 3 times negative 2x plus 7 equals 23. I knew what y was, so all I did was input that negative 2x plus 7. Now we have to isolate our x variable. So first we're going to distribute that negative 3. So 5x plus 6x minus 21 equals 23. 11x minus 21 equals 23 because we had to combine those like terms. Now our goal is to still isolate the x value, the x variable. So I'm going to add 21 to both sides. So 11x now equals 44. The goal is to get x by itself now, so we're dividing both sides by 11. When that happens, we get x equals 4. We're going to take that information and put it right back into equation 2. Y equals negative 2 times 2 plus 7. So y equals negative 4 plus 7. So y equals 3. We now get an awesome answer of 4, 3. Remember, always x and then our y. All right, let's go ahead and do a second example. We're looking for that coefficient of 1. Here we have a 1x all by itself, so we're going to actually isolate equation 1 this time. So here's equation 1. We'll go over here. We have x minus 7y equals 11. Our goal is to get x all by itself, so we're going to go ahead and add 7y to both sides. So we get x equals 11 plus 7y. We're now going to substitute into equation 2.
Hello, Stephanie.
So equation 2 is 5x plus 4y equals negative 23. So we're going to take this 11 plus 7y, and we're going to put it in for x this time. So we get 5 times 11 plus 7y plus 4y equals negative 23. We're going to go ahead and distribute the 5. When that happens, we get 55 plus 35y plus 4y equals negative 23. We're going to go ahead and combine like terms. Get 55 plus 39y equals negative 23. Our goal is to isolate that y, so I'm going to subtract 55 from both sides. Those cancel. I have 39y equals negative 78. Divide both sides by 39. And we get y equals negative 2. We're going to take that y equals negative 2 and we're going to put it all the way back up here to find our x. So x equals 11 plus 7 times negative 2. Alright, so we get x equals 11 minus 14. So x equals negative 3. So now we have that ordered pair, negative 3, negative 2. And then that's our answer.